Assume that you have two beakers. Okay, now in one beaker, let's say you have oil, and another beaker, say you have water. Now, if you pass heat to both of these substances, they're not going to have the same temperature after a period of time, correct? Let's say I'm going to boil, or not boil, say I'm going to pass temperature for about 2 minutes to both water and oil. Will the temperature be same? Obviously not. Here, the amount of heat energy taken by the system is different for different substances. Or we can generally say that it's a material property, correct? Now, this material property is actually characterized by specific heat capacity, okay? Or the specific heat capacity, this talks about the amount of heat energy taken by, not taken actually per se, amount of heat energy what is being absorbed or given by a particular material, okay? So, it is the characteristic of the substance. Now, to understand about specific heat capacity, very simple. Say delta Q is the small energy, the heat energy, okay? And say M is the mass of the object. Now, more the mass, more the energy we have to provide, correct? Like instead of, let's say, half a liter of water, if I'm going to put 500 liters of water, then obviously the heat energy has to be given more. So the delta Q is proportional to M, correct? Let's keep it. Then the next thing what we have, that energy whatever we are giving, it's proportional to the change in temperature, correct? So we have delta Q proportional to delta T. Combine these two together. Delta Q is proportional to M into delta T. Now to remove the proportionality, introduce a constant. So we get delta Q is equal to S M into delta T. Now that S is called as specific heat capacity. Okay, specific heat capacity. So now what we'll do, we'll make S as the subject of formula. So if you make S is equal to delta Q divided by M into delta T. Now specific heat capacity is what? The specific heat capacity of a material is the heat energy required to raise the temperature by 1 degree Celsius, or you can say a unit temperature of a unit mass of a substance. Okay, unit mass in the sense, suppose say you have 1 kg water and you are trying to increase the temperature by 1 degree Celsius. Let's say from 20 degree to 21 degree or 14 degree to 15 degree, whatever it is. How much of energy is it? How much of energy do you need to raise the temperature? That is called as specific heat capacity. Okay. So here it's completely dependent on the material, correct? Very easy to understand. Now the SI unit becomes, see, it's energy per mass per temperature, isn't it? So joule per kg per Kelvin. This is the SI unit. But then again, no one uses these things in regular life, as in, normal day-to-day life. What we use? We use in terms of the calorie per gram per degree Celsius. In the sense, how much of calories of energy is required to increase the temperature of 1 gram of water or any substance by 1 degree Celsius. This is what we call as the specific heat capacity of the material. Clear? This is what we call a specific heat. Now, there is another constant like this one called as molar heat capacity. To understand about molar heat capacity, here you need to understand the concept of mole, okay, which is quite a simple thing to understand. See, 1 mole is that mass in gram. You have to be very careful. It's in gram of any substance which is equal to its molecular weight. In the sense, suppose if I'm taking, let's say, carbon. Okay. Now, 1 mole of carbon weighs 12 gram, or 1 mole of oxygen is 16 gram. Okay, that's basically mole. In the sense, 1 mole, the mass of that is equal to the molecular mass of the substance. This is what we call as mole. Now what we are doing? Molar heat capacity. That means you have 1 gram mole of a substance and you are trying to increase the temperature of that substance by a unit temperature, correct? This is what we call as molar heat capacity. So mathematically, what do we get? C is equal to M into S. Okay. Now that capital letter M, that's the molecular mass. Now mathematically, see what we can do. We can write that N number of moles is equal to the mass in grams divided by molecular mass. See the formula? N is equal to M divided by capital letter M. If this is the case, then what do we have? Capital letter or small m is equal to capital M into N, correct? Now, where we are going to apply this? In the specific heat capacity. That formula was there, no? There we can apply. What was the formula? S is equal to delta Q by M into delta T. So, what is M now? N into capital M, right? So, S is equal to delta Q by Nm into delta T. Or take that capital letter M the other side. So, you get Ms is equal to delta Q divided by N into delta T. So, what is Ms? That's the value of C, right? The molar heat capacity. So, we get C is equal to 1 by N into delta Q divided by delta T. This is the formula for molar heat capacity. Clear? Again, I'll tell you, see, molar heat capacity is for 1 gram mole, but specific heat capacity is for a unit mass. That's the difference. So, for a specific heat capacity, I can take 1 kg mass, 1 gram also. But for molar heat capacity, you have to take 1 gram mole of the substance. Clear? This is the major difference between specific heat capacity and molar heat capacity of the two substances, or for two different types of characterizing about the substances. All right. So these are the two things, that is the specific heat capacity and molar heat capacity.